Okay, looks like it's about time to get started. So I thought we would first review the updates I sent out this morning or something, or afternoon, I'm not sure when it was. So I've revised the syllabus to reflect kind of what we've been talking about, and this up a little bit. Okay. So let's go ahead and make a good word of the day for the last day of new content. Any suggestions? How about sunset? Because there's one on my other computer screen. It's actually my high school too, Sunset High. Anyone else go to a Sunset High? Okay. I don't know if they're that popular or not. Anyway, so we'll do sunset as the word of the day. So the main thing you want to kind of just be aware of is, as I've been talking, what I've done is I've upped the score on the 3 exams. I think it was 30%, now they're worth 55%, but that takes, or they were 35% and the final was 20%, so I've basically put them together, so the 3 tests are worth 55%. Thing is, the final exam, it will depend upon you whether you take it or not, but the final exam is basically just the opportunity to retake each of those 3 tests, or individually or together. So depending upon where you're at with your grade, whatever you're satisfied, however, if you got 100% on an exam, I wouldn't retake it because you can't do any better than that. So but I've also spelled out here a little bit more that, so the first exam on Chapter 10 was actually worth 150 points. I've been adding 10 points to everybody who's turned in test corrections. I'll go through probably this weekend. Anyone who hasn't turned in test corrections, I'll add that in there. But if you can get your test corrections, that's kind of what I'm waiting for, to add that 10 points. So then it would be out of 150 points. The test we're going to take for 11 and 12 will be 240 points, which means each question will be worth 15 points, 16 questions. So it's worth a little bit more, but it's also the more applicable stuff. The first part was a lot of theory. 11 and 12 is a lot of applications of derivatives. And then the last section will be back down to 160 points because it's only going to be really like 3-4 chapters or sections that we'll be working on. So just the integration part and then the applications we'll talk about tonight. It will favor primarily Chapter 13. And the primary thing I think is the one we're going to do tonight will be the primary part for the last exam as well. So then the other part is that 14.1 and 14.2 have been taken off the schedule. They're no longer required. But if you do them, you can still earn the points as extra credit. So I think I've got that taken care of. I think all the homework, I think I've got enough in there for 400 points. The attendance, I did start actually up. The attendance quizzes are actually now each worth 4 points. So I added points for those because that gives you 50 points out of 1,000. So those have been updated. And then just there's this updated schedule. And it really just affects, we can see tonight we're going to do 13.4, and that will, what we do in 13.4 will be the primary basis for what we will do in the next test. I won't test you on the numerical and graphical 13.3 where we were doing Riemann sums. That's really just to get you to understand how to do it, but it's very tedious. And if I had the app, I would download it, and it makes it easier. We could do it. But other than that, it's just tedious. What we're going to do tonight is actually take the derivatives, and you're going to see, I'll show you both ways. You can do it with your calculator. Will actually get it very nicely for you. and we can also do it algebraically. So we'll do both, and it'll be good to have some practice with that. Yes?
Did you ever post the word of the day for 13.1?
Probably not. I might. That's what I was wondering. I was going to check on that, and I got busy with something else this afternoon. So I'll check. I probably don't even have the video uploaded yet, or it's in YouTube. But I'll after class when I do this one, I'll make sure that one's up there as well. Good. Good. Okay. And so then what we have for next week is really just an open lab. I will be here both days, both Tuesday and Thursday. You're welcome to come, but there won't be any planned content other than to work on practice tests. So this weekend I will try to get a practice test for this last one done as well. And then what I'm going to do is once I've got the exams open, I'm going to keep everything open through to July 19th, which is the last day of class. So you work it into your schedule. I don't know, for me, I'd rather get them done, but I want to be ready, and I want you to get them done as soon as you can, but I also want you to be ready. So work it into your schedule. So just we just got those things. So we'll have all of next week to pick up anything that you want to go through with homework or with practice test questions, anything that you might need. Okay, but we'll kind of just be open. If you have a few questions for the good of everyone, at the beginning I'd be happy to do it as a class, but what I find is usually one or two people have different questions. So we'll just work through it. Okay, so that's the rest of the class. And then the week of July 10th, that's when I leave. I will be available by email still, but I will have some online reviews for the exams and such so that you can go through those, check in on them. And then the week of July 17, I have a substitute arranged. So the Tuesday will be kind of a day to, if you had any questions, you'd have a person here. And she's actually the coordinator for this class. So she teaches it. She chose the content, the book we've been using, so she's very knowledgeable about this course. She will be here again on the Thursday, which is an opportunity. If you wanted to take the final in here, we could work that out. But again, the final, you may not need to take it. So it's really, again, just a collection of the 3 tests, depending upon how you do at the other tests. But she will be here so that if you had questions. And again, if you're fine, you might be done with the course by then. That's perfectly fine. No requirements to show up after that. Any questions? Yes.
So are test corrections available for the second and third test?
Yes.
So when are those due?
Yes, but you could, because if you get July 19th, everything's due by July 19th.
Oh.
So, because you can email them to me, either with a legible picture. I've had some students send me a picture, but it was so fuzzy. I said, "Really, you expect me to?" So make sure it's a readable picture, or a scanned image is usually best as a PDF. But yeah, you can get those back to me that way, and we're all good. So yes, I'll because I do believe that's helpful, because sometimes in the testing situation, even though you've gone over it with the practice test, sometimes something didn't work out, but later on you're able to see it. So we'll do that. And then again, you've also got, if you've completely, again, it's hard to think of how you would completely fail it unless you didn't do the practice test. If you do the practice test, you know you're going to be fine. So take the time to work through it, make sure you understand it. And I'm going to have some videos this week, the July 10th, on how to work through them. Okay. So we are streaming good. Okay, so everything seems to be going well. This down. Yeah, so I got, there was one correction on the practice test. There was a 2 equal sign. The second equal sign should be a minus sign. It was on question number 3. And I've got it corrected now, so if you download it, you can get it. And on the solutions, I have got it corrected. And the solutions I went through pretty painstakingly, working through them step by step. So hopefully you'll find that part helpful.
So 5x minus 0.00?
Yeah. instead of that equal sign. Okay, so tonight we've got one section that should be easy after what we showed last week in comparison, and then one that's applications that's a little bit challenging, at least I thought so. So we'll see how we do with it. And okay, let's see, where is this? So let's come over here. So what we're doing tonight, we've been integrating. So they use this little thing that's kind of like, looks like an S, and that's really what it's for, because an integral really is a sum. What do we start with when we're asked to take an integral? We're starting with the derivative. Very good. So let's make one up here. Let's go with 2x squared minus 4x plus 3 dx. So what is a derivative? It's a rate of change. So it's how things are changing. It's a rate. And if you were to take a rate over time and add up all those slivers, what you get is an integral. That's why we're summing up the effect of those rates. So think of it, if you work at a ballpark or a concert or something, you could keep track of how fast the people are coming in, how many people per minute are coming in. And it might be at the beginning, it might be a lot, and then it slows down as you get close to the event. Fewer people are coming in because everyone's already in there. So the rates might change over time, but if every minute you kept track of the rate per minute, and you added all those up, you'd come pretty close to figuring out how many people were in that stadium or that arena. Okay, so that's what we use rates for. And in business, the same type of thing. The applications we're going to use is income. We know the rate that income's coming to us, and so we'll use integral to figure out how much income we get over a period of time. Okay, so what we start with is this is a rate. When we integrate it, we get back to the original function, and it turns out that again, well, let's go ahead and go through this one. How did we go about integrating?
You added 1 to the exponent and then divided that 2 by the constant.
Very good. So it was kind of backwards of what we did with derivatives. So instead of subtracting 1, we add 1, and we do that first. That gives us a new exponent. Oops. Remember how to add. Remember, adding 1 was one of the very important parts of this prerequisites for this class. And then what did we do with that new exponent? We said we divided it by that. So this becomes 2/3 x to the third. And we do that term by term. So this had a 1 up here. We're going to add 1 to the exponent. So that's going to give us an x squared. And then we take the new exponent, divide the old coefficient by that. So that would give us a minus 2. 4 divided by 2 is 2. And then when we had the constant term, when we integrate that, that's always just going to be plus 3 to the x. Okay. And what am I missing?
Plus c.
Plus c, because there was a potential for a constant here, but if there's a constant, it became 0 when we took the derivative, so there's really no way knowing what it could have been. We just know that there's this possible constant somewhere. Could have been 0. But there's ways to find out, but in this class we're not going to worry about it. Okay? We're just going to go there. However, tonight, what we're going to add to the mix to make things a little bit more doable is you've got this rate of change, and if you're going to sum it up, what do you need to know about this summation? What's that? The intervals. When do I start counting and when do I stop counting? Hey boss, you know, you want me to start at the beginning of the show and out, you know, when do I start, when do I stop? So I need limits, and if I have those, the constant won't matter anymore. So this is what we do tonight when we have the limits. This thing really is much nicer to work with. So this is what we were working with last week. This week we're going to take that same function, except this time we're going to give it some limits. So they're saying let's start at time 0 and maybe go for 5 minutes or whatever x is, right? We'll go from 0 to 5. And again, someone remind me, why do I have that dx there? What is it? Good. Remind me it's a derivative. That in there is a derivative. So when I integrate it, I'm getting back to the original function. But it's a rate function that I've got now. So we go through the same process. And again, I've already got it up here, right? We kind of went through that process. So you'll get a little bit faster. It's 2/3 x to the third minus 2x squared plus 3x. Okay, so I've integrated it, and then what you'll see is I put just for the notation wise, is kind of put the limits back here. I'm not sure if the book does it exactly like that, but that's how I was taught. And then it'll spend some time explaining why this works, but I'll just tell you it does, so we'll, you know, I guess. If we take the two limits, the two endpoints, and we subtract them from each other, the one in the future, the older or the higher number minus the lower number, we actually get everything in between. Okay. We get the area under the curve, but it's the area under the curve of the derivative function. So it's accumulated what's under the derivative function, and that's what we're looking for. How much total did we get? Okay, and so it's, again, in this one I probably chose too many x's to really do this, but you'll see it's not too bad. So I plug in 5 for each of the x's, and then I'll subtract off this function when I plug in 0 for each of the x's, and I'll get a number, and that's my answer. Then I'll show you how you can do that graphically. Okay, so we do this 2/3 times 5 to the third minus 2 times 5 squared plus 3 times 5. And then we subtract off the lower limit being plugged into the function we just got the integral of. We just integrated. I'm going to put this parentheses because you got to remember that negative needs to distribute to everything. If you want to just mentally do it as you go, that's okay too. But I'm just going to do it this way so I don't mess up. So I get 2/3, and you'll see why I chose 0. 0 is a nice lower limit to have. Minus 2, 0 squared, plus 3 times 0. So it looks like we're going to get 0 on the bottom end, and not a big deal. Okay, that's why we like zeros. But we don't always get it that easy. Okay, so we see that, yeah, this is 0. 5 cubed is 125. I better not try to do it in my head. In fact, actually, if you wanted to, you could plug it in to your graphing function and then just look it up in the table. I'm just going to do it step by step. So 2 divided by 3 times 125, that's 83.33. Five squared is 25. 25 times 2 is 50. So there's going to be minus 50 there. 5 times 3 is 15. So if we add all this together, 83.33 minus 50 plus 15, we end up with 48.33 repeating. But we'll go to 2 decimal places, and that's the answer to our integral, doing it algebraically. And again, on Tuesday, we were doing it with rectangles and counting how many rectangles and getting a really poor estimate. Anyway, it was a lot more work.
Would it be negative if you're subtracting from 0? Oh, no, never mind. Sorry.
Good. Okay. So that's the hard way to do it. But did that look too hard? Not too hard, but that was the hard way. Would you like to see the easy way? Of course, good. No, we like to do it hard. Okay, so the easy way is what we're going to do is come over here. I'm going to switch over to the calculator. Easy way, and again, you know, business folks, time is money, so you want to find not only the easier way to do it, but the quicker way and the way that's less prone to human error. As you could see, I could make some pretty good errors there, right? Usually I do. But this way, the cool part about this, you actually don't even have to integrate. Oops. But you do have to remember what the problem was, and I just erased it. Oh, that's right, I can get it back. Do this. There it is. So what you put in is you put in the equation or the function that's you put in the derivative that you've got. Okay, so we're going to put in the 2x squared minus 4x plus 3. Oops. 2x squared, arrow down to get out of the exponent, minus 4x plus 3. And again, you might have remembered I did show you this kind of quickly last week because there was a question that came up, isn't there an easier way to do this? And I did show it to you. That's what today's lesson is. So this gives us a graph, and what I'm going to go is I'm going to go to my window to set my limits. What was my limits? 0 to 5, so I'm going to go x minimum 0, x max is 5. You could go bigger, but I like to just, this is all we need to worry about is 0 to 5. I don't know about the y's. I'm just going to leave them, and then I'm just going to hit the graph and see what we got. Looks like it worked pretty good. We want to integrate this, and we want to go from 0 to 5. So what we do is we use the tool here under the calc functions. It's blue, and it's above the button, so we have to hit the second button first. We go to calc, and there's our integrate the function button. So we just need to go down to number 7 or hit number 7, whichever way you like to do it. And then it asks us where's our lower limit. Now we've set the window, but it doesn't know that that's what our limit is. So we just have to tell it lower limit's 0. So I just hit the 0 button, and then I hit enter. Then it asks me for the upper limit, which is 5, and then I hit enter. And then what it does is kind of cool. It shows me exactly what it's finding. It's the area under the curve, and it gives me that answer. Doesn't that look familiar? It's exactly what we came up with after all that handwork. And notice we did not have to integrate. We just put it in and then use the calculator tool. It'll work for the whole 13 problems. Now you're like, dang, I'll be done in 5 minutes. And that's fine. It'll work on the test. The only time it might not work is if you're asked to integrate, but the answers are what is the integrated part, what is the new function, and there'll be a few of those. Because that's really what we were doing in 13.1. We were just integrating, and then we were doing plus a constant. So those will be that way. These questions will be with the limits. You could do them all with your calculator if you wanted to.
So it's measuring the area under the graph.
Yes, and remember that graph though is a rate graph, so it's the rate of things. So we're literally adding up all those little slices, all those little minutes of how many people have been coming through the turnstiles, and when we get the total, what it is it's how much we've accumulated. And again, it could be a problem where we've got a leaky faucet or something, how much water got accumulated. It could be a hole in the boat, how much, could be a oil spill, how much oil is accumulated. It gets used in business primarily for things like profit and revenue. We know the rate that the revenue is coming in, and so we could do the time period, and those are the problems we're going to look at specifically too. So it works for all of those. Any kind of accumulation type problem where things are kind of building up. And again, we're starting with the rate. But it's the area under the rate curve. Questions? No questions. Okay. So, any questions about how to do it with the calculator? Do you see it go in slow motion or anything? The buttons, not too bad. If you can graph, set your window, and you don't have to necessarily set it from 0 to 5. Just, I think if you had it set from 0 to 4, you might have problems. You have to have it big enough to see the domain they want, but it can be bigger. But just, basically have it within the domain, do this, you'll see it visually, and you'll get the answer that you're looking for. I wish they would have had this when I was going to school, but I guess that was okay. So come back to here, just a reminder, 48.33, that's exactly what we got. So these two do the same thing, algebraically, technology-wise, okay? And a lot of things, get into business statistics, you're going to plug your data in and let a statistics program do all the work for you. You learn statistics just to give you an overview of it, but you got to learn how to use the technology to manage it. You've got to know what you're getting, that this is a accumulation under a curve. Okay, let's do this. Let's take a look at the homework, because I think that's how I'm going to go into the next. Oops, where am I? Oh. So I'll give you the option again. We'll take a look at what the homework looks like. If you see one that looks challenging, or if you want to take a look at, we'll take a look at it. Down there, go to student view. Let's see, where are we down here? So it's 13.4. Remember, 14.1 and 14.2 are now extra credit if you want. Area between two curves, we do a little bit of that in 14.4, so you'll be able to see those. But the definite integral with algebra, let's just take a look at 12 problems. This one going from -5 to 5. Look okay. Again, do it algebraically or graph it. This one, maybe graph it. Algebraically would work too. It's just going from 0 to 1. It's probably not going to be too bad to do algebraically. Not too bad. From -1 to 1. Again, graph it. How about this one? We okay? Go slowly. Zero to 4. How about 5 to the x? Sure. Can you?
Probably not.
Probably. Well, you actually on your calculator you could, right? And that's why you're probably saying, hey, I could just plug in my calculator. Why do I need to? We'll do both. But yeah, you're right. I was kind of big, and someone please say they want to take a look at this one. This one, remember 5 to the x is an exponential. So this one, remember, you kind of get thinking forwards and backwards. When we take the derivative of 5 to the x, what do we get? We get itself, right? So the derivative of 5 to the x is 5 to the x, but there was also something else that came off of it. Remember? Natural log of 5. Good, good. I don't even remember, was it over the natural log of 5 or was it times the natural log of 5? Is it something like that? 5 times the natural log of 5? I think so. I should have checked. I was being too confident. Those are the things you just don't do enough. Yes, sir.
If you have like a parabola, what would you use as like a lower and upper limit? If you have both sides kind of being both.
Well, I always use the lower and upper limits. These that they give us, those will be your x values, and then the y's you just have to place. You just have to make it till you could see it, and so it depends on the graph. So if I'm going to integrate, see, I can't. It doesn't integrate just to 5x because if I take the derivative, I get this extra stuff. So when I integrate it, what do I need to do? I actually need to divide by this natural log of 5. So that when I take the derivative of this, right, I'll get 5x times the natural log of 5, and the natural log of 5 in the bottom comes along as a constant. These two cancel out, and that's what I have here. Okay. So it's a little tricky one, but you just, we didn't do a lot of exponentials. We did maybe 1 or 2, but that's how you would do it. But to be honest with you, so this is what it integrates into between 0 and 4. So you could plug it in, but to be honest with you, the way I would do it, so I would come here, just put in 5 to the x, and then what was our boundaries was 0 to 4. So I'll go to my window, 0 to 4. I'll leave my y's at where they're at, and we'll graph it. It's going to go up like that, pretty fast. Second calc, number 7, and lower limit was 0, upper limit was 4, and it fills it in. And even though I don't have the top, looks like maybe my window I didn't change, I don't know. Anyway, I had 5, okay, I wanted to go to 4, but I guess I got too anxious. So my answer is 387.713. Now, let's just do a little check to see if that works. 387.713. Back here. They don't tell us how many decimal places to use. So, better use them all. 387.713. Oops. 387.713. Submit the answer. Didn't like it. Okay, why didn't it like it? 0 to 4. Let's see. Now let's see what we would have got. 5 to the 4 over natural log of 5 minus 5 to the 0 over the natural log of 5. 5 to the 0 is 1. And this is 5 to the 4th. Which is going to be, is that 625?
Mhm.
625. Over the natural log of 5. So you could since they have the common denominator, you could write this as 624 divided by the natural log of 5, right? 625 minus 1. Let's see if they're being real picky, if that's what they're looking for, because they didn't tell us how many decimal places. Can't get any more exact than that. Let's see if that works. That worked. Okay. So there, yes.
For number 1, like using the calculator, it gives you an exact number, but it wants a fraction.
And what number does it give you? Oh, so let me see.
Go to the first problem. Can you do it the calculator way?
Uh-huh.
It's going to be wrong.
And so it's asking for a fraction.
Yeah.
That's how they got tricky on us. Okay. Yeah. Darn, I should have tried them. But, okay, so we've got, so we're going to integrate it. Let's see, that's going to be x to the 3rd over 3, right? X squared, add 1 to the exponent, divide by that, plus 5. When we integrate it, it's just going to be 5x. Okay, so this is the integrated portion. We're going to go from -5 to 5. Let's see. You submit answers by questions. You're required to use a new randomization after every 3 submissions. Your last submission used for your score. Okay, so again, the first thing we get is we're going to get 5 to the 3rd divided by 3 plus 5 times 5 minus -5 to the 3rd divided by 3 plus 5 times -5. There's this parentheses here, so make sure that goes through. 5 to the 3rd is 125 over 3. And that's what they're doing, is they're probably, there is a way that they can say they want a fraction, which I guess is okay, plus 25. -5 to the 3rd is going to be -125 over 3. But remember, there's this negative out here. And 5 times 5, a plus and a minus, is going to give us a -25. So when this negative comes through, this becomes positive and this becomes positive. So these two terms we add together, 250 over 3. 25 plus 25 is 50. Let's see if that's good enough. Because yeah, 250 divided by 3 is going to give you probably a repeating decimal. But this should give you an exact enough answer, I hope. Yeah.
Do it the algebra way.
Yeah, I guess for the ones that are going to, because yeah, if you got the decimals, I would maybe, just the way I am, I would try them with the calculators. The one that works, I would do it. The ones that don't, I'd go back and do them by hand, because that's, you know. But there should be some in here where that should probably work. But that's always a good way to check your answer. You know, turn it into decimal, then check it with the calculator. Good thing we found that one out. Okay. So any questions? So far so good. Okay. So again, e to the x is going to be nice. Yes.
Sorry.
No problem. I thought this one, because this one just is its own integral, so that one's pretty cool.
So it's like the one that we're talking about.
The marginal cost of producing the it's hard to say, box of light bulbs is that function. So that's, remember, a marginal is a derivative. That's really all they're telling us. So we've got a derivative function here. Determine how much is added to the total cost by a change in production from x equals 30 to 90. So what the words are saying is take the integral and your limits are 30 to 90. Okay, because they're wanting an accumulation. But you're right, these are, it's not set up, so it's, what are they really asking? But all of these will be, the function they give us is always some kind of a rate. 11, they're giving us a velocity. A velocity is speed, that's a rate. And so we're going to integrate it, and the times are going to go from 1 second to 6 seconds. So yeah, let me just, so this question really just narrows down to asking what is the integral of 6 plus x squared over 1,000. And we're going from 30 to 90, put our dx. And again, I would try it first with the calculator and see if that works. If it doesn't, maybe they need, they've got it restricted to some exact answer. But I would do that one first. This one down here is really the same thing. They're giving us the function. This function is a rate function. So the question is really asking us to take the integral of 80 minus 32t dt from 1 to 6 seconds. Okay, so we integrate it, we plug in those boundaries, or we graph it, and if it accepts our answer, we're okay. Ball is blank feet lower after 6 seconds than it was at the end of the first second. A ball is thrown in the air as velocity at the time t seconds. Find the total displacement of the ball. So yeah, so your total displacement is how much has it traveled between times t1 second, t6. So whatever you get here will be the same numerical answer, it's just in words down there. And not too many of those. And this last one, the rate of U.S. per capita sales, so it's the rate, so this is a derivative because it's a rate, is given to us, where t is time in years since the start of 2000. Use a definite integral to estimate the total U.S. per capita sales of bottled water from the start of 2000 to the start of 2010. So again, you're going to be looking at the integral from 0 to 10, starting in the year 2000, going to 2010. Now your problem might end earlier, so whatever this is our end value. And again, we're just going to take the integral of this. Okay, so integrate, go from 0 to 10. You'll see that the 0 is nice because the bottom part drops out. You don't really have to subtract anything. You just get the top part. And on some of these applied problems, using the calculator may work with them. And again, that's always my first way, is try the easy way first. If it works, I move on. If not, I'll come back, and there'll be enough of them that you can practice by hand. There should probably be a few that work with just plugging it into the calculator. Sound good? Be okay?
That's by hand.
What's that?
That one's by hand.
I don't know.
The last three you can
I thought, yeah, I was thinking usually the applied problems, they'll do them. So I know there's somebody that's probably faster than I would that would get that answer to us before we finish. So yeah, the last three, set them up, put them in, and your calculator will get you the answer, and it'll be good enough. You got it. So let me save that one. Oops, where are we? Okay. Yeah, it's a little tricky. Now, if the calculator would take it, I mean, if we could put it in the calculator if it would take the answer, but it obviously doesn't, right? So you try that one. So, okay. So let's try to integrate this thing, and this is when we're integrating. It's sort of like factoring. Factoring in algebra generally is hard, right? But when you factor a trinomial and x squared, right? You'd sort of do a guess and check, and then you FOIL it back out to see if it's the right thing. So this is similar. So what I'm going to start with is when I take the derivative of e to the x, what do I get? E to the x. So it's its own derivative. So I'm just going to start with that, e to the minus x plus 6. So if I start with this, what I'm going to do is I'm going to take the derivative and see if I get back to what's in that integral. Okay, and I'm going to play a little game. If it's not exactly what I want, I'm going to get it to be what I want. Okay, so if I take e to the x, if I take what I've got here and I take its derivative, what do I get? Derivative is going to be, like we said, it's just e to the minus x plus 6. But remember from the chain rule, we then also have to take the derivative of the exponent. What's the derivative of the exponent? What's the derivative of negative x plus 6? It's the derivative of negative 1x plus 6. Negative 1, right? Because negative 1 is there, and then you subtract, and that becomes x to the 0. So that's just 1. Derivative of 6, since 6 is a constant, is 0. Derivative of constants are 0. So when I take the derivative of negative x plus 6, I get a negative 1. So in taking this derivative, what I end up with is I end up with this with a minus 1 out front. Maybe I'll put it on the back side. I get a negative 1 coming off. Do I have a negative 1 in what I started with? No. So what I have to do is I come back and say, well, if I put a negative here, when that negative comes on, a negative times a negative is going to become positive, and that's what I'm going to end up with. Okay. So I had to I went back and forth between, and that's really the best you can do with these e to the x's. Start with assuming that it's just its own integral, take its derivative, and whatever you end up getting that you don't want, you divide it out. Okay. Could have thought of this as e over -1. Okay, so this is the integral, and then we're going to go from 0 to 1. And so what I get is I get negative e to the -1 plus 6 minus negative e to the -0 plus 6. Okay, so if I follow through, I get negative e to the 5th, right? -1 plus 6 is 5. Negative and negative make a positive, and 6 plus 0 is 6. And I'll bet you that's what they want for the answer. They don't want you to plug this in and get an approximate. They want you to enter negative e to the 5th plus e to the 6th. I think this should work, hopefully. Okay, it liked it. Okay. So there are a few in here they kind of want exact answers on. Yeah, I would prefer just let's plug it in and do it, but it's a little trick. Does that make some sense? Kind of. Okay. So do your best on them. Again, remember we got all next week, so if they don't work out for you, next week we can work on them in class too. Okay, just getting through them. The ones I'll put on the test will be more of your polynomials type, and since it's multiple choice, all you gotta do is pick the right answer. You'll be able to get close enough. You'll be able to use your calculator. So especially once you've practiced these, the test questions will seem easier. Yes. You got it. So let's save that one. Back to 12. Yes.
So for the limit on this one, is it 0 to 10?
Yes. This one's 0 to 10. Now, your problem might be different if whatever usually it's the red that they change, so if it was like 2009, it'd be from 0 to 9.
Yeah.
And it doesn't look like they're going to change the start date, so the start would always be 2000 because it's starting in 2000. But that's where they could get tricky on you, change both. Okay. How's that? Okay, so now we're going to take a look at a few applications from economics, and we'll go as long as we can go. Okay, so we'll put this down for now. We'll come back to get a few problems. There are for the homework for 14.4, there are 1, 2, 3, 4, 5 different concepts that they have homework on. Now, in the textbook itself, they introduce a few others, but none of those problems are in your homework. So the first one is what they call consumer surplus. Then there's producer surplus. There's also total value, future value, and present value. The thing is all of these are integral type equations. They're application ones, so we'll also, once we get them set up, that's going to be maybe the harder part of it, we will be able to use our calculators to get the actual values. I'm hoping. I haven't tested them all, but the ones I worked, we were able to do that. Okay, consumer surplus. Anybody an economics major here? Anyone taking economics? Good. So did I, like 50 years ago or something. A long time ago. But we'll see what we can do with this. Okay. So what's a customer surplus? Well, supply and demand, right? What happens if, when do you get greater demand for something? Yeah, because everyone wants it because you can't get it, so less supply. But how about in terms of price? Lower price, more people will want it, right? The higher price, some people will still want it. And right, scarcity, if it's a one-of-a-kind thing, everybody wants it. So what consumer surplus, and then we'll see producer surplus, is basically the same thing, but from a different perspective. So what we have on the y-axis is our price. Price goes up or down. On the bottom is the number of quantity that people are going to demand. So as the price goes down, people will want more. And if you think of it as a function, it's maybe backwards, but this is how they're doing it in the book. So they'll show it like this: as the price goes down, people want more. And you get some kind of demand function maybe like this. And so they call this the demand function d of q. So it's based on, is that right? It's kind of weird. The d of q, yeah. So the q is our x. How much demand there is at a given price. Okay. And then when this price here is there's zero demand, this is basically the maximum price, because if the price was any higher, people wouldn't want it at all. So the y-intercept gives us our max price. So anyway, what this is about is, what if they were producing something and they said, well, let's just let's start selling it at this price here. What you get is that if you start selling it at that price, you get this kind of demand going, and so basically you save the consumers this money up here, because the idea is that you start at what you can maximally get, and you keep bringing the price down as you sell one more, because there's some people willing. You've gotten all the demand as you bring the price down. But what you've done is, I guess you've left money on the table, so they call that the consumer surplus. Sometimes that might be a good thing to do because you leave more money in the consumer's pocket. They could go use it to buy something else, like food or something, okay, gas, whatever. There's more money left in the economy. So they're just kind of saying, if we know some of this, if we know what the demand curve looks like, and we decide to sell basically at a lower price than what we could get for something right now, we're going to generate some surplus in the economy. And believe it or not, if you can kind of see this, the area under the total curve, and remember, demand curve is really at what price we're getting things. It's really a rate. So they call this point here Q bar. They call this height here P bar. So what we end up getting is that we get an integral going from 0 to Q bar, which which is how much demand there would be at that price. We're going to integrate the function. And that would be the area, all the area under the curve. What we're going to subtract off, though, the surplus is the part that's in this triangular region up here. Okay, so then what we have to subtract off is the rectangular area, which is P bar times Q bar. This simplifies, again, this is what we're going to use, simplifies down to, we get the integral from 0 to Q bar. This Q is integrated into the function itself, so you could just take the function that we're given, subtract off P bar, and if we get this integral, that's our consumer surplus. Okay, so in the bottom line is all of this is more had been a description about what consumer surplus is. Mathematically, we just need to be able to set this up. And it'd be nice if they gave it to us as a problem, but they won't. They're going to tell us that the demand function is such, and they'll tell us where the P bar and the Q bar is possibly, but we're going to have a little bit of mathematics that we do basically to figure this out. And the other thing that I didn't put up here, where is it? Well, that this function d of q is always equal to p. So p is like your y, q is like your x. Okay, and so the other thing we're going to need to know is that d of q bar, if we plug that in, if we knew it, that gives us p bar. Okay, they're just, p bar is just some number that they choose, some price. What if we started, we could sell it for $5, but hey, we want to sell a lot, so we'll sell it for $4. So they're going to leave some money on the table because there were some people willing to buy it at $5 who will now buy it for $4, and they saved some people $1, they saved some people maybe 50 cents. And so we want to be able to calculate those. So maybe write those down, and what we'll do is we'll look at a couple, well, we'll look at one problem like this. We'll look at another one that's similar, which is called the producer surplus. But in the homework, I think there's like 3 or 4 of these problems. Okay, so let's see how we apply that. So here we are. Over here. I now see why I had this over 2 days, but I thought, well, and if you get too tired, we can just say, in fact, I think I might get like halfway through and we'll pick up the rest next week. But the last couple applications are kind of really good ones because you can for anyone, is anyone in finance or looking to get into finance? How about marketing? Possibly. Okay. Finance and marketing, you might use some of the later ones. Of course, marketing, you might use surplus, and you might not. Who knows? Depends on what part you're in. Okay. So here's a couple typical type problems. So calculate the consumer surplus at the indicated unit price P bar for the demand equation. So let's see this example. So round it to the nearest cent. So I think that's where we're going to have the help, is they're wanting us to round, I believe. We should be able to use the calculator once we get it set up. The hard part is going to be to set it up. Okay. So they tell us they've got this function p equals 14 minus 2q. So this p is, it's like our y, that's the function. So what we know, oops, I gotta come over here. So what we know is that from what we've been working with, the function d of q, remember, equals p or equals 14 minus 2q. Oops, q. P bar equals 3. So if P bar equals 3, what is Q? How do we find that one? Because remember, what we're looking for, let's see, where should I put this so that we can, we'll do it up here. Our formula is we go from 0 to Q bar, D of Q minus P bar, which is just going to be 3, so that's a nice little substitution, dq. But how do we find Q bar?
Make it equal to 3.
Excellent. This function equal to 3. So it's a little bit of algebra. So we say 3, which is P bar, equals 14 minus 2. And remember, this is a Q, but it's a special Q. It's the Q bar. Okay. And so now we solve for Q bar. Subtract 14 from both sides. 14. 3 minus 14 is negative 11. And then divide both sides by negative 2. So we get a positive 11 halves, which is 5.5, right? That's what our Q bar is. So now we've got our Q bar, we've got our P bar, and we know what our function is. So what we're being asked to solve is to take this integral from 0 to 5.5. Where's our function? 14 minus 2q minus P bar, which is 3, dq. Okay. Now you could simplify. You could take 14 minus 3 and put your negative 11 if you wanted to. I'm just going to make sure I don't make any mistakes. I'm just going to put the whole thing in the calculator, go from 0 to 5.5, get my answer, and let the calculator handle all the details. Okay. Find that I make fewer errors that way. And we're going to do this together so that we can make sure that the system actually will accept it. Okay, so what I do is once I've got it set up, again, remember that's the hard part really. But was it super hard or was it not too bad, was it? I didn't do it before class, so I was scared, I'll tell you that. Because I don't like to look foolish, but I figured I might look foolish tonight. I probably will before the night's over, but hey, that's why I get paid the big bucks, right? So we're going to go to y equals. Okay, so we put in our function 14 minus 2x minus 3. There we go. Again, you could simplify it if you want, but I'm just going to put the whole thing in there. I'm going to go to the window. We're going from x of 0 to 5.5. Again, you could make it bigger if you want. I like to just, look at what I need to see. I'm going to go from 0 to 25. I think that'll work. Yeah. So that brought it in. So it's going down. Yeah, by 5.5, that's what it is. So then what do we do? How do we find the area underneath that curve? Anyone remember?
Oh,
Yeah, good. Calc 7. So calc, there it is, number 7. You could just hit the 7 button, goes right into it. It'll ask for the lower limit. Our lower limit is 0, enter. Our upper limit, 5.5, enter. It shades in the area and gives us the answer of 30.25. And let's hope the thing accepts it. So we're going to now switch back over 30.25. So most of our work was to get it all set up. You could have done it by hand here, which is fine. But 30, what was it, 30.25? Yeah. Which means, yes.
So Q gives us our domain,
Yes, Q is our X.
but our maximum domain.
Right.
Assuming we always start at 0, considering.
Right, because 0 would be we didn't sell in, because Q is how many things we're going to sell, and you don't sell less than 0. So, but usually you're going to start at 0. They could, yeah, because that's if you would have started at the max price, so forth. So let's see if it works. It worked. Okay. Now remember, subtracting that 3 off. That's the reason we're doing that. Is that's the part that we would have naturally got. So what this means is simply that we've left an extra $30.25 out in the consumer world that we could have gotten into our pockets, but now it's out in the consumer world. Maybe that's helpful for our other businesses or something, or for state economists. We want to leave some money out there so it's out floating around. I think you could probably apply the same thing if you were in the tax business. We want to give some tax cuts to leave that money out there. That's typically why they want the tax cuts. Not so much that they want you to have a nice life, but they want you to spend that tax cut to make their economy better.
So like petroleum companies don't use this at all.
Probably not. They want to max. Yeah, they want to get us. Although a little bit, because they figure if they leave some money on the table that maybe you're willing to, that maybe you get some loyalty to their particular brand. So sometimes there's, our marketing people, there's reasons why you maybe don't want to maximize your profits, because taking a little bit less might in the long run get you more. Yeah. Although I'm glad I wasn't an economics professor. So, and again, so you'll see we get some kind of more funky type question. This is Q to the 1/3, but you don't have to worry about taking the integral, because these ones will work on your calculator. You basically got a function, you got a starting value, but you remember finding that Q is going to be probably the tricky part of it. We okay with this, or do you want to take a look at it?
And you would just do the cube root, right?
Yes.
Okay.
So it's a cube root. So you're actually, to solve for Q, or to solve for P, actually you're going to plug in the P, you got to solve for Q, you're going to cube both sides. Yes. So it's a little bit of algebra, and that's kind of what you're going to be doing through here. So I'd be happy to help you with that part. Again, the calculus part actually will be fairly easy, because you put in the calculator and that'll do the calculus for you. It's the algebra to figure out those boundaries. Okay. Here's another one. Here's another one. Okay, this one's not too bad, but it's a quadratic. So yeah, to solve for, put in the P. Oh wait, actually you've got to solve this one for P first, but I think I'll let you kind of work through these. So yeah, I think I'll take the easier ones, and this is, but remember, this is, I'm thinking I'm still like 20 points behind, so maybe I'll double the value of this particular, I got to get you up so that you get full 400. But this is kind of going to take the place of 3 lessons because the other parts of 14 are just extra credit. Of course, you could look at them. I think if they seem easier, you're welcome to do those, right? Same points. 20 points is 20 points. Let's go ahead and take a look at producer surplus, and then look at the 2 other concepts. But I think once you get to producer surplus, that's, see, we're already up to 6. Here's another producer surplus, and then we get into total value, which is not too bad. So, okay, so we got 2 problems with producer surplus. So what is producer surplus? Just a little off track. Anyone else watching the World Cup? Who you rooting for?
England, I guess.
Okay, that was mine because my wife wanted Belgium this morning, so I have to give her what she wants. And they are my ancestors. So anyway, so England. Anyone else?
I ran out of teams.
Yeah, we were supposed to go for Germany. That's my wife's favorite, so I was going to go for Germany, but they didn't even make it. So how about you? Mexico, yeah, that's actually I'm hoping Mexico goes all the way because they're getting such bad press from our country right now. So I said, and remember, we're on land that was it belonged to, actually probably technically still belongs to them. It was taken from them in a war. So we're almost like Mexicans. At least we should be, right? So, okay, producer surplus. The concept here is very similar. Except what producers want to do, this is sort of the reversed psychology. They would sell more at a higher price. So, if you're only going to give them this much, I'll sell you a few of them. But if you want more, you're going to have to pay more. So the producer's surplus, the producer's curve generally has a positive slope. It's going up. So that's our surplus based upon quantity. They'll sell more for a higher price. Down here is the Q, the quantity, and so the surplus is if they sell it here. Let me change colors on this. That what they end up getting, if we sell it at that price, they actually pick up all of this too. Okay, so we sell it at a price higher, and so here's their surplus. They gain some extra income off of this. And again, it's an area under the curve type problem, but without going through all the painful details, it ends up being, if they give us the producer surplus, if they give us the surplus function, we're simply going from 0 again to this point, which is going to be Q bar. But their surplus starts off at whatever P bar is over here. And then you subtract off this bottom part here, which is the function value. So now you're subtracting off, oops, that's not a very good S. S of Q dq. Okay, so they're going to give us a function. Sorry, the P should have a bar on it. There we go. They should give us either P bar or Q bar, and from that relationship we'll be able to find one or the other with some algebra. And then once we've got the integral set up, we can graph it, use our graphing calculators tools to find the area under the curve. challenge is going to be finding either Q bar or P bar. Depends on, I think most of them they're going to give us P bar. And then we got to use the function they gave us to find out what Q bar is. Okay, because it's the X value. Okay. But again, it's just same concept, but this is from a producer standpoint. And so if you sell at a higher starting place, they'll sell more and they'll make more. Okay, so we're going to save that. We're going to take a look at that example and see if we could kind of think our way through setting this up. Okay, so this is a producer surplus problem. So we use a producer surplus. And remember, on the test, when the test time comes, this is stuff you'd want to have in your notes. I wouldn't try to... Should I even test you on this? What do you think? Are these good test questions? I didn't think so. Yeah, they're good homework problems, but that's why I'll focus on the ones from 13.4 and 13.1 are really the two main sections, that maybe the exclusive sections, because I think I'm only going to have, I have to have fewer problems. 60, well, I can still do about 15 problems, but I'll just take them out of there. Okay. So the supply equation for the equation indicated the unit P. Okay, so, oh geez. So it's a supply equation. Q equals this. We want S of Q, right? So if we want P as a function of Q. So what we have to do is over here, we have to solve this equation for for P. Because remember, P is like our Y, Q is like our X. Okay. You might even, if you wanted to, you could even change them, but then that might confuse you as much as anything else. So we want to get P by itself, so we add 50 to both sides. So we end up with Q plus 50 equals 2P. Divide both sides by 2. And so we're going to get P equals Q over 2 plus 25. So that's our function. Wait a minute. No, they want, yeah. So this is, Q is the input in this kind of a function, so what we've really got is that S of Q equals Q over 2 plus 25. Remember from our formula, producer surplus equals the integral from 0 to Q bar P bar minus S of Q dQ. So do we have everything that we need? We got P bar here, that's good. We've got S of Q here, that's good. What are we missing? Q bar. Okay, so to get Q bar, just like we did last time, we've got P bar. So we take this function, we put in 59 for P, so we're going to end up with Q bar divided by 2 plus 25. We're going to solve this, and that'll give us our limits. Okay, so notice most of our work on this problem is not really to to answer the question. That's all going to be done by the calculator. All our work is just to get the dang thing set up, which is a problem itself. So we subtract 25 from both sides. That leaves us with how much? 32? 34? Thank you. My mind is just getting like fried, and my arithmetic is really going to be poor tonight, so I need help, all the help I can. Then we multiply both sides by 2, right? So that cancels. So Q bar is going to be 68. Is that right? Anyone else do this? Like you just kind of work and your work's all over the place? That's how I do it anyway. So you're just seeing direct from the mind. It's a mess in there. But we've got our pieces. We've got our Q bar. We've got our P bar up here. And we figured out our function. That's the tricky part, that what they gave us was Q is equal to this. We needed to get the inverse function. So what we need to set up is the integral from 0 to 68. P bar is 59 minus S of Q, which is, and again, be careful here, make sure you put the function in a parentheses because that negative has to apply for everything. Q over 2 plus 25. And again, you could simplify this thing, or you could just plug it in as it is, which is what I would do, which is what I will do, and we'll find our answer, and we can enter it in. Okay. Questions? Yes.
Up there you have PS equals, yeah, is that 5Q or 50Q?
That's SQ. That's the, yeah, S of Q. Sorry. That's why I don't like using S's, because my S's look more like a 5 than they do an S. Let's see if I'll... S of Q. Okay. So let's go over to the calculator. We'll go back here, clear. We'll put in our function, which is 59 minus parentheses x, what is it, divided by 2, plus 25, close the parentheses. The window, the boundaries is going from 0 to 68, so I'll do that for my x's. I'm not quite sure what to do with the y's, so I'll just go from 0 to 100. And again, probably don't have to worry about the price going below 0, so 0 as a minimum works. Because remember, the y value is price, yeah. I think that's good. Let's see what we get. Didn't even need to go to 100. Get a graph like this. How do we find our answer? Second calc, number 7. It's going to become your best friend. Lower limit, 0. Upper limit, 68. And we find all of that in between. Okay, 1,156. So that is the surplus, the additional amount that the producer was able to get because they were able to sell it at a higher price from the get-go. There's some, this is what happens when there's shortages, when there's wars or something, or natural disasters. People will come in and take advantage, reap a big profit, and they call that a producer surplus. And again, I guess depends on who you are or what your beliefs are, whether that's fair to do or not. I guess if you're the one that got hit by the hurricane. You're not real happy that people are making a profit off of you, are you? Let's see. I need to, so 11:56. So we're going to come back here. But I mean, that's the only reason why I think consumers would pay more than what they would usually pay. What was it, 11:56? Yeah. Let's check it. I'm hoping I'm in. See if it's right. Okay, it's good. But honestly, I'm nervous because I didn't work this before, so you know. But that's what you need to do with these two. How we doing? Had enough for the night? So I could keep going, but I'm starting to feel like Ferris Bueller's teacher right now. So why don't we do this? We'll take the opportunity to go through. This will get you through the first 7 problems. The next ones are dealing with total value future, which are all kind of related. So how about if we pick those up first thing on Tuesday for those who are interested? I'll see how you do on these, and you should be fine. These are also ones I'll put a video on. So you've got, just remember, due dates for everything is now going to be moved to July 19th, which is the last day of class. So you kind of choose your schedule. You've got 3 more weeks after this. This is the end of it, but 3 full weeks to get through everything. Okay, so we'll pick up a little bit. There's just 3 more topics, and they're very closely related, but they're different than what we just talked about. So I want you to give these a try. Again, the challenge is getting them set up, but we'll work on those together and see how far we do with those. Pick up the other ones. Maybe work on the 13.4 because that's what the test is going to really focus on. But I think by the time you're done, you'll be doing okay with these. And then next week we'll have a little bit, maybe 30 minutes. We'll cover up those last few problems, and then anything else you have questions on, we can work on them either together or separately or groups. This over the weekend, I will get the Chapter 11 and 12 test posted. What I will first do is finish up the solutions guide. I think I had the first 6 questions or first 7, first 6 or something. I got those solved. Those are in Canvas, and I sent out an email. I will finish solving the rest, so there's the solutions there, sort of step by step. Then I'll post the test. But again, I really want you to go over that practice test and understand it clearly before you take that test. Because if you do, you won't have any problems. You get a page of notes for the test when you take it. And again, remember, you will just need a webcam, and you can take it anytime, any place there's internet. Yes?
For the instructions, when you say only 1 page of notes, do you need like 2 write on, or if you need any?
You can have as much scratch paper as you need, yeah. And
It's not talking about to do your work on.
no, yeah, you can have as much scratch paper, so you can have a notebook there. You scan your environment, and here's the things. You could do it a big piece of, now it could be legal paper, right? I didn't say, I just said a page. I've had people bring it like this, so that's a page. So I'm not too, yeah. Have what you need. The thing is that sometimes if you have if you have everything, but if you go through the practice test, you'll know exactly what you need. But I'm not trying to test your memory, I'm trying to test your ability to apply. So I want you to have the notes that you need. So, yeah.
Okay.
Yes.
The study guide is expensive as the last one, so I feel like I knew everything, the test, just by doing the study guide.
Yeah, because that's what I did is the study guide, I went into the homework and I took 2 questions out of each section. And when I make the test, I take the study guide and I change the functions, and that's all I do. So yeah, if you do this, basically change the numbers, it's just you'll do the same processes as the study guide, just with different numbers. So that's my goal, is that you should be able to go there. And this is even more so. The last one was more theory. This is this test is a lot of just application type stuff. So
This is test 3 or
test 2.
Okay.
Test 3 is sort of the stuff we did tonight. The first part we did tonight will be test 3. Don't worry about that. I'll get working on that, and sometime next week it'll be posted. And then basically, you've got till the 19th to take 2 more tests, finish up the homework. If you don't do well on the test, what are you going to do? You're going to take the final. If you do well on it, what are you going to do with the final? Sayonara, I'm not going to do it. So basically you get 2 chances to take the test.
You said that it's take 2, both 2 by the 19th. Is what I'm doing?
Yeah, because the 19th is the final day of classes. And again, if you need a little bit more time, I'm going to be out of the country anyway. Actually, I'll be 14 hours ahead of you all, so I can give you an extension over the weekend and stuff. I'm not going to be too critical. Heck, I might be floating down some river or something. Who knows? But so I'm not too worried. I don't have to have grades in till the week after all that. So if you can, that'd be good for probably you and me both. But if you need an extra week, I can give you up to an extra week. I would rather you get the time you need.
Well, what I'm wondering is like this second test that's coming up. Has the same due date as the third one.
Yeah.
Combined.
Yeah, but it's 3 weeks down the road. So I just said, get it done when you can. Make sure you're ready for it. But yeah, I'm just going to say everything to do. Give you 3 weeks to do it. Not worry about the due date. Let you set a more restrictive due date on yourself than I would. Yeah.
And the solutions to the 11 and 12 exam are posted already?
Yeah, in fact, let's go ahead and take a look at them. So let me save this one. And actually, I think I can just pull it up from...
And that's available tomorrow, starting tomorrow?
Actually, it's available now.
Oh.
If you go, if it's in Canvas, and I'll show you where it's at. I also sent out an announcement, so if you got that email, it should be attached to the email. So practice test solutions, let's go ahead and pull that up. It's right here at the top. And what I did is I went step by step. I did some colors, so I sort of probably did more work than I needed to, but I wanted you to see, how do I take the derivative? I multiply by the exponent, then I subtract 1 from the exponent. So I went step by step on everything that's happening. Again, you might not do that. I probably wouldn't do it if it was my own work, but I wanted you to see what I was doing, so that even if I've had some students that they wait till this time and that's when they learn the material. That's fine. That's what I'm interested in, that you learn the material. So however that happens. So I think you find these first few ones I'm showing you exactly what I did. I took this 2 down here and I multiplied it. I'm subtracting 1. So there's the answers. Here's set up the profit function, take the derivative, so it's step by step, all the way through there. All the problems. Here's one with a product rule. I worked it with the product rule, and then I also foiled it out and then did it that way. So some of these I did multiple ways. And if it's helpful, great. If it's not, well, I'm sorry. But I'll also do a video of them maybe, so that you could also do it next week. But that will probably come after I get everything else done. So I'll get the paper version done, and then I could do a video where I sort of speak through it. So, because some people learn more auditorially, okay. And then there's one with the quotient rule, and again, I just kind of painstakingly went sort of step by step, and hopefully it's here's G prime, here's H prime, then put it together, and then do the algebra to simplify. And then again, remember on the test, when you actually go to take the test, it's multiple choice. You just got to choose the right answer. These ones are more open-ended to get you to practice. Usually those are a little bit harder. But on the test, sometimes you'll be able to just pick it out. So I got these 6 done. The other ones I think will be a little bit quicker. And maybe by tomorrow or certainly by the weekend I'll get that posted. And then from there I take this and I make a test out of it. I'll get that posted, set that out. And again, you can take it at any time. If you're ready, go ahead. If you're not ready, just take your time in getting ready for it. And then my next goal is to work on the 13 and 14 test, put that together. Again, I've always put a practice test together first, and then from that practice test is how I make the actual test.
And we'll do that next week.
Yeah, and so my goal is to have that ready for you. My goal is to have it ready by Tuesday so that we have those time in class to kind of, at least you can see it, see what it's going to be like. If you have questions, we can work through it while I'm still here. Because the next Thursday will be my last physical presence here. You know, you still get with me through email, and I have another professor coming the last week of class who will be available to answer any questions if you have them. All right. We good?
And we don't really have to worry about the homework until.
Yeah, it's all due at the 19th. It's all open. There's no due date. There's no, as far as web assign, whatever Canvas says is a soft due date anyway. So, yeah, you've got till the 19th. So you got 3 weeks to complete all the work. Put it in on your schedule where it fits. If you want to get done early, great. If you want to wait till the end, that's fine. And if you need an extra week, it can be done. So just let me know. All right.